वीडियो अटक रही है,
हम्म
वीडियो लैग हो रही है मेरे साइड से।
यहाँ से तो आ रहा है। एनी इश्यू विद वीडियो?
No, sir.
Okay. So this problem came in net 2017. So to do with this constant voltage drop model, they given you 10-volt battery. Okay, there is a diode. There is one more diode. Okay, and this is open circuit. So they are asking, seriously, saying this current is I. They are saying this current is ID1, and this current ID2. So they say find I plus ID1. Okay, so it is pretty simple question. The resistance value they have given 1 kilo ohm, and they say diode are silicon. Okay, silicon p-n junction. So you can replace them by 0.7 when they are forward bias. Okay, and of course you can see when you make them open. Okay, so open circuit voltage is 10 volt in this point, so they all are conducting. Okay, so we can replace them by battery when they are forward bias. When they are forward bias, we can replace them by a battery of 0.7 volt. Okay, similarly this is also 0.7 volt. Okay, now I can apply KVL in this loop, so I can find 10. Okay, say current is I, resistance is 1 kilo ohm. Okay, plus 0.7 equals to 0, and this gives me I equals to 10 minus 0.7 upon 1000, that is 9.3. Okay, 9.3 milliampere is the current. Okay, so 9.3 milliampere current is coming here. Okay, now this current is getting divided between two diodes, because both of these diodes are similar, so half of the current will divide. Okay, so I can say ID1 and ID2 is equals to 9.3 upon 2 milliampere. Okay, and if you solve this one, how much will come? It will come 4 point how much come? 4.65 milliampere. Okay, and they are asking question, find I plus ID1. So I plus ID1 will be how much? I plus ID1 will be your 9.3 plus 4.65. Okay, and if you add them, they'll give you 13.95 milliampere. 13.95 milliampere. So simple question. Okay, let us do one or two more problem on constant voltage drop model. Okay, then we'll do piecewise linear model. Okay, where you have to replace diode with a battery plus with a forward resistance. So yesterday I gave you homework. Okay, you people have notes given me. This is 12 volt. Okay, here we have a silicon diode, and then you have a germanium diode, and there we have 5.6 kilo ohm resistance. Okay, I asked what is the voltage here. Okay, and current ID. What is current ID in the circuit? And what is the V naught? Okay, so this is silicon diode. So if this forward bias, okay, so this is looking forward bias now. If you see open circuit voltage, okay, that will come 12 volts. So this is a forward bias. So you can say this is 0.7 volt. This is 0.3 volt. So you can write minus 12. Okay, you can replace by a battery. Okay, so 0.7 plus 0.3. Okay, and circuit say current is ID, and that will be multiplied by 5.6 kilo ohm resistance. 0. Okay, I'm applying KVL in this loop. So your ID will be 12. This become how much? 1. 0.7 and 1. Okay, so you can write this become 11 total. 12 minus 1 upon 5.6 into 10 to the power 3. So this become 11. 5.6. Someone mic is on. How much should come?
1.96.
Okay, this will come 1.96 milliampere. Okay, and V naught is obvious. 0.7 here, 0.3 here, remaining V naught will be here what? 11. And out of 12 what is here, so 11 will be here.
Sir, how is V0 11 volt?
This total is 12 ना, और 1
sir.
यहाँ पे ड्रॉप हो रहा है तो बाकी बचा हुआ कहाँ जाएगा? Remaining will come here. Now if you want you can calculate, you know ID into R, you can do same come 11 volts. Okay, you know ID already, so ID into 5.6 kilo ohm dollar, you will come 11 volt. Or it's a simple thing. Voltage, sum of voltage should be 0. Okay,
$10.97, that is 11 coming, sir.
yes. So this is your silicon, this is your germanium. Okay, so this is your 10 volts, and here you have resistance. One resistance also is there. Okay, the resistance is of 100 kilo ohm. Okay, so they are asking what is the current in the circuit I. What is the current I in the circuit? So how should I do this question? So you know this circuit has a 0.3. Okay, and while this is 0.7, both are forward bias. Okay, now if current is flowing through this one, this will become 0.3 battery. Okay, so because this path has a least resistance, less resistance. Okay, because as soon as I start connected with battery, current will start flowing this one. Okay, and this current will go from here, here. No current will go from here. Okay, because once there is a voltage drop 0.3 volts here, once there is a voltage drop 0.3 volts here, 0.3 volt here. Okay, now suppose this silicon is not there. Okay, and the current is flowing like this, you're getting 0.3 volts here. Okay, now suppose if I add some silicon here. Okay, now this silicon cannot conduct because this voltage is sufficient to make them drop, make this conduct. Okay, because once you have already 0.3 voltage drop here, now something you add, okay, this voltage cannot rise to 0.7. Okay, if you add something less, it can reduce, but it can never go never never increase. Okay, because this here voltage in this terminal is now 0.3. So this diode will not conduct. The silicon will not conduct. Okay, the silicon will not conduct. So current will not pass through here, and current only pass through here. So you apply this minus 10. Okay,
सर ये
plus
first
0.
जर्मेनियम
Yes.
यही पास क्यों होगा?
What you say?
सर ये फर्स्ट जर्मेनियम से पास क्यों होगा? मतलब सिलिकॉन में फर्स्ट क्यों नहीं जाएगा?
जर्मेनियम के पास में वोल्टेज ड्रॉप कम है ना, कट ऑफ वोल्टेज कम है ना. Okay, if you see IV characteristics of germanium
IRA
silicon. Okay, so germanium this one. So once it is goes to germanium and then current start flowing. Okay, so any amount current will flow here. Okay, so if it is not burning. Okay, so once this is 0.3 volts, that will become fixed here. Now once 0.3 fixed here, that cannot rise to this one. Okay, so the current will choose the path where is the least resistance. Okay, so this will go through this one because your silicon is 0.7. Okay, so current will not go from here.
फिर ओम्स का ही निकाल रहे हैं ना, लगा रहे हैं हम कि वोल्टेज जिसका कम है उसका रेजिस्टर भी कम होगा, सो
ये ओम्स लो तो नहीं लगा रहे हैं यहाँ पर. यहाँ पर क्या है कि ओम्स अब जैसे दो रेजिस्टेंस होंगे तो करंट तो जाएगा ही, दोनों में जाएगा, चाहे कम हो ज्यादा हो. अगर ये जीरो है तो फिर सारा उसमें जाएगा, अदरवाइज तो करंट डिस्ट्रीब्यूट होता ही है ना टू रेजिस्टेंस. बट करंट करंट का प्रॉब्लम ये है कि रजिस्टर का प्रॉब्लम है कि रजिस्टर आपका वोल्टेज को फिक्स नहीं करता है. हियर you see the IV characteristics. Once current flows, the voltage get fixed here. Okay, now their voltage is 0.3. Okay, either it can be 0.3 or 0.7. Okay, but once it is a 0.3, now it cannot rise here. Okay, voltage drop cannot change. अब यहाँ पे 0.3, वहाँ पे 0.7 कैसा रहेगा? एक ही रहेगा ना voltage तो. Okay, so this becomes 0.3 and this becomes your current coming I into 100 kilo ohm equals to 0. If you calculate, this will come 9 and 10 minus 0.3 upon how much? 10 raised to power 5. So this becomes 9.7 into 10 raised to power minus 5 ampere current. Okay, let me do one more problem. Now this is not a constant draw voltage. This is, say, two diodes are connected back to back. Okay, and I'm applying some 5 volts here. So says, what is the voltage across this diode? Okay, so first of all, tell me whether if I connect this type of diode back to back, whether there will be flow of current or no, whether there current will flow or not. Tell me yes or no.
will not flow.
No, sir.
Why?
Because both same terminals are close by na.
So this is forward bias. Okay, and this is reverse bias. So but at least reverse bias current can flow na, at least reverse saturation current flow na. Whenever if diode is in reverse bias, if I'm making reverse bias, so at least I saturation current can flow minimum, isn't it?
Yes, sir.
Okay, so reverse saturation current can flow when diode is there. So at least in the circuit, your I naught will flow. Okay, I naught current will flow. Now I know the I naught current is flowing here, so I can find what is V1 V2, because once I know the current equation is I naught, okay, exponential QV upon KT minus 1. If I take eta equals to 1, ideal case, okay. If I take eta equals to 1, ideal case, okay. So I can write my current equation also like this: I equals to I naught exponential V upon Vt minus 1. Okay. Now I know that in the circuit, current is flowing is I naught here. Okay. So they say this is a forward bias. So I say this is my V1. Okay. And I say current is flowing circuit forward current. Okay. I naught is flowing. So I can write I naught by I naught. Okay. Then exponential V upon Vt minus 1. Okay. This cancelled. This become 1. Okay. And 1 from here go. So I can get exponential V upon Vt equals to 2. So I can find my V1. V1 is what? Ln 2 into Vt. Okay. And Vt value you already know at room temperature. Vt value is 25 milli electron volt. Okay. Or 26. So you can, I'm using 25 here. So 25 into 10 raised to power minus 3. And what is the value of ln 2?
0.69.
Okay. 0.693. 0.693. Okay. So if you multiply this thing, okay, you can get what the value of V1. Okay. So if you multiply this one, this will give you the value equals to how much? 0.173 volt. 0.173 volt. Okay. Now you know this V, you know this V1. You can find what is V2. Okay.
Sir,
Yes.
how we write V total equals to 25, sir?
This is VT.
Yes, sir.
VT is what? KT upon Q, na? VT. KT by Q, and that is equal to 25 millivector 0.0225 electron volts. Okay, that is 225 milli-electron volts
Okay, sir.
at room temperature. Okay, so if you solve this one, okay, now you have -5 plus V1 plus V2 equals to 0. Now you want V2, so it will be 5 minus V1, and 5 is your 0.5 minus 0.173. Okay, minus how much will come? Tell me. So this will come around 4.982 volts. Okay, you can check the calculation. So most of the voltage getting drop here. Since here the minimum idle current is flowing, so voltage drop is very less. Here forward bias and remaining voltage is dropping here. Okay.
0.0173.
Hmm?
V1 hours is come out to be 0.0173.
That you can check. Okay, 0.173 or 0.073. Check. You can check. Okay. So this is 10 to the power minus 6, 600. Okay, 600.
Only voltage in yeah. No, LN2 is 0.693 only na.
0.693.
So 0.0173.
Okay. So you can correct whatever value. I don't know. Others, please tell what is the value? 0.173 or 0.0?
Zero.
Point
Sir,
zero
ये
one
वही
seven.
तब हाँ जी.
This is correct, huh? This is correct, huh?
Yes, sir.
Okay. So then final you make it minus and tell me what is the voltage. Okay. I have
सर
this
ये
value.
तभी आ रहा है.
Answer 4.982.
ठीक, okay. So 173. Okay. So now next model is piecewise linear model. Okay. Piecewise linear model. So piecewise linear model says that you have this is actual IV characteristics. Okay, you replace this IV characteristics by somewhat this type of IV characteristics. Okay, so you have I, you have V. So here we are assuming that when we have to consider a model, we are assuming that diode resistance is almost zero. Okay, but because diode is a finite resistance, so this is your actual. Okay, or you say this is your actual. Okay, and we are approximating this by like this graph. Okay, so whenever diode is in the circuit, okay, in forward bias, you have to replace it by a battery as well as a forward resistance RF. Okay, in forward bias. Okay, and the reverse bias, of course, when it is forward bias. Okay, and in reverse bias, okay, in reverse bias, you can again replace it by open circuit, or if very high resistance is given in the question, that is equal, na? If open circuit or high resistance is given, then you can replace by an open circuit. हाँ बोलिए.
सर ग्राफ में दो चीजें कैसे क्या मतलब करंट एंड वोल्टेज का जो दो ग्राफ
भाई ये तो ग्राफ तो है आपका, this ideal is the actual graph. Okay, and this is we are approximately, this is our approximation. Okay, this is our approximation. This graph I'm approximating by this graph.
फॉरवर्ड बायस होंगे ना सर फॉरवर्ड बायस के केस में हम अप्रोक्सीमेट करते उस साइड पे
Forward bias. So now this line you see, this is this line is a finite slope. That means you have finite resistance. Okay. So now I'm replacing, and this voltage is same. This voltage is same for silicon 0.7. So you need now, you have to treat diode like a battery as well as it has some finite resistance. Previous case, it has a zero resistance. Previous to previous case, ideal, it has a zero drop and zero resistance. Okay. In second case, it has a finite drop, resistance zero. Now it has a finite drop, 0.7 and finite resistance both. Okay. आगे चले. Okay. So let me solve you one problem. So they have given you a resistance, a 5-volt battery, okay, and then they give you diode, okay, and they say diode cutoff voltage V gamma is 0.65 volt and R forward is your 20 ohm. That much is given. Okay, so what I will do now, so and the resistance is given 1 kilo ohm. You say find the ID value. So it is simple now. What I have this diode, I have a resistance. I will replace diode by a battery of 0.65 volt, which is given as a cutoff voltage, and they are given a forward resistance also, that is 20 ohm, and this is my 1 kilo ohm resistance. Okay, this is a 5-volt battery. So I need to find current. Now you can find the current very easily. You have simple circuit. Okay, we can write -5 plus ID into 1 kilo ohm. Okay, then plus 0.65 volt and plus again ID is flowing in 20 ohms equals to 0. So you have -5 plus ID become 10 1020, okay, plus 0.65, okay. So ID become now 5 minus 0.65, okay, divided by 1020. So this will give you 4.35 upon 1020, okay. Tell me what is value coming?
4.26 milliampere.
Okay. So you'll get 4.26 milliampere. Okay. So working is same what we did earlier. Only now there's extra resistance coming.
सर फॉरवर्ड रेजिस्टेंस कितना था 1:10
46 milliampere.
Forward resistance are 20 ohm. Forward resistance are 20 ohm. And second resistance था 1 kilo ohm. Total resistance हो गया 1020 ohm, 1020 ohm.
फिर ये जो फॉरवर्ड रेजिस्टेंस दे रखा है वो इंटरनल रेजिस्टेंस होता है।
क्या होता है?
इंटरनल
भाई डायोड का कुछ ना कुछ रेजिस्टेंस होगा ना, ओके। डायोड है, कुछ बीच में कनेक्टेड है। इंटरनल मतलब इंटरनल रेजिस्टेंस तो जनरली सोर्स का होगा, एनर्जी सोर्स का होता है, ओके। ये तो एक बैटरी सोर्स तो नहीं है, बैटरी तो कुछ हमारा एलिमेंट है, इसका भी कुछ ना कुछ रेजिस्टेंस होगा ही, एक्चुअल रेजिस्टेंस, ओके। हालांकि ये रेजिस्टेंस एक्चुअली वेरी करता है, ओके, बट वी आर टेकिंग ए फिक्स कांस्टेंट। Point to point it varies, okay. Now you have been given a 5 volt, you have 1 kilo ohm, and then you have here VD. V gamma is given 0.5 volts and RF is given 1 ohm, okay. So you need to tell me what is the value of VD. What is the value of VD? Okay. So first of all, we have to replace this by a battery and a resistance of 1 ohm, and this is 0.5 volt. Okay. Now I need to find what is VD here. So VD will be this voltage plus this voltage. Okay. So first I need to find the current. So -5 plus, say current is ID. Okay, -5 plus ID into resistance is 1 kilo ohm, that is 1000 ohm. Okay, plus 0.5, and say here the voltage drop here is your ID into 1 ohm 0. Okay, so I will be having ID into 101. Okay, this will be 5 minus 0.5. So ID will be your 5 minus 0.5 upon 101. This is 4.5, 1001. Okay, so the current should come around 4.496 milliampere. 4.496
Coming, sir.
milliampere.
Yes, sir.
This current is flowing here, one ohm resistance. Okay, this current is flowing this across this one resistance. So the voltage drop total I can write now my total VD. Total VD I can write is 0.5 plus ID is 4.496 into 10 raised to power 3 milliampere into 1 resistance. Okay, so that how much will come total VD? So total VD will come around
0.50.
0.50. Okay, so let's just check it. Okay, this current is going like this. Okay,
2.5042.
5042. Okay, so this should be the answer. So 4.496 will be dropped. 4.4 volt will be here. Remaining 0.502 or 5044, whatever saying, will drop will be here. Okay. So you can solve whatever questions given. Okay. Now we are starting your. So okay, you want to do more problems on this model, or is enough?
Yes, sir. Send me more problems, sir.
Okay, I'll send more problems. But you have to send, do the solution and send me. Okay. Okay. Now just I'm giving you one more problem. You tell me. Okay. You have to tell me the solution. So you have, say, this problem already we have done. This is 6.2. This is 3.23. Okay, and then you have a diode here. $100 ohm. Okay, so this question you will replace diode B gamma from 0.7 and the RF is 20 ohm. Okay, and you need to tell me what is the current flowing in the circuit. This is your homework. We already solved this problem with constant voltage drop model and ideal model. Now just add the resistance here and tell me.
Current to the diode we have to find out now, or current to
Yes,
the
yeah, current to the diode ID, not this one. This current you need to find out ID. Okay, I'm giving you answer also. Just check it. Okay, it may not be same. Okay, 2.3. So the current should be, just 1 minute, 100. No, you have to find out current. You need to find current. Okay, I don't have answer. And I'm giving you one more problem. You have been given this diode. Okay, so this is here I'm giving V input. Okay, and this is your 2 mega ohm resistance, and this is your 5 volt battery, and here I am measuring V naught. Okay, and my B input is like, V input is my a square wave. Okay, B input is like a square wave of 50 volts. 50 volts, and this is your minus 50 volts. Are you getting that? Like we are giving sine wave, now I'm giving a square wave. And this is when you're treating diode are ideal, so RF is 0. Okay, he said diode is ideal. Diode is ideal, and diode is ideal. Okay, so V gamma is 0 in forward bias. In forward bias, they are saying RF 0, V cutoff 0. But in reverse bias, this time they say replace it by a resistance of 3 mega ohm. Are you getting my question? The diode is forward bias is behaving like an ideal. So cutoff is 0 and RF is 0. So when it is forward bias, you have to simply make a short circuit. But in reverse bias, you should not make it now open. Okay, because reverse bias very high resistance there. That's why generally we make it open. But this time they have given the value of reverse resistance 3 mega ohm. So when it is reverse bias, you have to replace by this by 3 mega ohm. Okay. So when it is 3 mega ohm, when you're applying input this one, you're getting some output. So you need to tell me what is output for reverse bias and forward bias, and you have to plot together and send me. Okay. Question is clear?
What is VR in the first case? फॉरवर्ड बायस में RF से VR लिखा है वो क्या है?
See, forward resistance भाई. Whenever if it is a diode is forward bias, in that case you have to treat by ideal diode. Yeah, this is ideal diode, na? This is ideal diode.
और VR रेजिस्टेंस वोल्टेज होगा फॉरवर्ड बायस में VR
cut off voltage है भाई. Cut off voltage is 0. Okay. That means you have to simply replace by short circuit. And this is your reverse bias. Okay. In reverse bias, you have to replace by 3 mega ohm resistance. No battery, no cutoff voltage. Okay. So this is problem second. And I'm giving you one more problem. Third problem is
सर सेकंड में क्या करना है?
क्या चीज?
सेकंड प्रॉब्लम है.
सेकंड प्रॉब्लम में जो
Sir,
पूछा है वही
second
करना है. सेकंड प्रॉब्लम में जो पूछा है मैंने कि आपको आउटपुट बताना है और क्या आउटपुट इनपुट ड्रॉ करना है. और या आउटपुट बता दो, सीधी तो बता दो कि फॉरवर्ड में कितना आउटपुट है. यू टू ड्रॉ इनपुट एंड आउटपुट कर्व. Okay, so this is your V input is given. This V input is given to you. Okay, and this is your V output, which I'm measuring across this resistance R. Okay, this is your diode say D1. This is diode D2. So this is the V input graph. Diodes are ideal. Diodes are ideal. So this is your V input graph. Okay, you have to send me what is V output graph. This is V out. Okay, what is this V out I'm using here? To tell me what is the V out graph. Okay.
Sir, there is a resistance
So
in the. Sir, this
what thing?
resistance.
Resistance value?
Yes.
Yeah, resistance value I have to give you. Just 1 minute. Resistance you keep it R only. Okay, no issue. Resistance will not create any problem. You say resistance value is R. Because I'm not giving you a value here also, no? You need to just show the variation, how it is varying. Because these are models, so whole the voltage will be drop only across resistance only. There will be no drop voltage. So magnitude will be same, V input or V output. Just you need to show me the variation. Okay. Are you getting my problem? There is no other voltage drops in the circuit. So whatever voltage drop, that will be across R only. Okay. Now I'm starting that Zener diode. Okay. So what is Zener diode? Okay. So Zener diode means you have an ordinary diode. Compared to ordinary diode, it has a high doping. Okay. And if I see the IV characteristics of Zener diode, this is I. Okay. This is V. So this is my IV characteristics, and this is a breakdown. And here you have a same what we have done earlier. Okay. So this is your Zener diode in forward bias. Okay, your Zener diode behaves like a ordinary diode. Okay, in forward bias, your Zener diode behaves like an ordinary bias, and reverse bias. In reverse bias, okay. So mainly its main use of Zener diode is in reverse bias. Okay, because Zener diode is mainly used as a regulator. Okay, regulating the voltage in the circuit. And it acts as it works in a reverse bias condition. So you see, whenever diode is in breakdown region, okay, so there will be some Zener breakdown voltage, we call it VZ. Okay, and there will be some current flowing in the circuit, say IZ. I call it I minimum, and it can flow up to IZ max. Okay, current can flow from IZ minimum to IZ max. If current goes beyond IZ max in the diode will burn out. Okay, so there is a performance parameter for Zener diode. Okay, so Zener diode comes with a maximum. The Zener diode comes with the performance parameter that is called VZ. Okay, so if I write a performance parameter of Zener diode, performance parameters. Okay. So every Zener diode come with a data sheet, okay, where the VZ value will be given, okay, and then IZ max value will be given, and then it will be PZ max value will be given, okay. So you cannot allow current more than IZ max through the diode. So whenever diode is in reverse bias, okay, its voltage gets fixed. Whenever Zener diode is working in a reverse bias, okay, they have a fixed voltage. When we apply that fixed voltage, after that the voltage across the diode become constant, but current can vary. Current can go from IZ minimum to IZ max. Okay, a Zener diode require a minimum current to operate. Once the minimum current is flowing through diode, okay, it is will become it voltage will become VZ, more current to adjust the, because it has to work as a regulating circuit, as a regulator in the circuit. Okay, so it has to adjust the current. So current can vary from this range. Okay, but voltage will be fixed. While current is varying, they will maintain the voltage VZ fixed. Okay, so the first thing, your Zener diode, number one, Zener diode, okay, we use in Zener diode, okay, works in reverse bias for regulation of voltage. So whenever I want to regulate voltage in the circuit, okay, Zener diode has to be put in a reverse bias condition. Now, how we can treat Zener diode in the circuit? Okay, so whenever there is a Zener diode in the circuit, this is a symbol of Zener diode. Okay, so in forward bias condition, in reverse bias condition, when this type of voltage applied, okay, when diode is in reverse bias, in reverse bias, we will replace Zener diode by a voltage source called VZ. Okay, we'll replace this by a voltage source called VZ.
सर वीडियो बीच बीच में स्टक हो रहा है.
स्क्रीन भी अभी ब्लर हो गई है.
अभी ठीक है अभी. Okay, so these are the performance parameter. Okay, so every diode comes with the data sheet. Zener diode comes with data sheet where it is written what is the Zener voltage value, how much the maximum current value it can flow before. Okay, or what is the safety current value, and how much once current value is fixed, automatically VZ is fixed. So your maximum power it can afford. Okay, or safe performance. Okay, the safe performance of a diode, what is the maximum power that is equal to PZ max. So those values will be given in the question. Okay, so I'm repeating again. Whenever Zener diode is in reverse bias, you can replace it by a battery. Okay, and forward bias it will work like an ordinary diode. Okay, in forward bias, okay, it acts as a ordinary diode. Okay, now what do you mean by ordinary diode? Ordinary diode means the voltage will be given. Okay, either it will be really like an ideal diode, so the voltage drop will be 0, or some cutoff voltage will be given in forward bias condition like 0.6, 0.3. Okay, so it's really like a ordinary diode. Okay, so
मिनिमम की वैल्यू सेम ही होती है, मतलब आइजेड मिनिमम की.
सेम मतलब
मिनिमम हम जो डाटा शीट में वैल्यूज देते हैं उसमें VZ है, आईजेड मैक्स है, लेकिन आईजेड मिनिमम की वैल्यू
आईजेड मिनिमम के लिए जरूरत है ना. आईजेड मिनिमम सेफ्टी पैरामीटर नहीं है ना, वो तो हमको चाहिए जरा सा. ये जो रिवर्स सैचुरेशन करंट है, generally this reverse saturation current is equal to your IZ minimum. Okay, in some question you can take IZ minimum also 0 also, because this is in microampere. Okay, so compared to this current flow in a circuit, this current is negligible. Okay, so sometimes we can take 0 also IZ minimum, but this current is very less. Okay, almost equal to your reverse saturation current IZ minimum. So I will solve the problem, then we understand. Okay, so I'm not starting that Zener diode regulating circuits. Okay, that will start tomorrow. So that time we'll discuss again what is Zener diode. Today I'm giving you a simple problem of Zener diode. Okay, you tell me. So you have a power supply, say 12 sine omega t. Okay, and you have a Zener diode. Okay, given the circuit with a resistance R. Okay, and this is your plus minus, this resistance is R. So you tell me you have to plot input output curve. Okay, so this is Zener diode. You have been given a power supply, okay, of 12, peak to peak value is 12. Okay, this is my V input. Okay, and I am measuring V naught here. So you tell me what is the value of V naught in the circuit, and the VZ value for Zener diode is given 6 volt. Okay, so that means when it is 6 volt, you can replace by a battery. Okay, and otherwise okay, otherwise it is ideal. Okay, so reverse bias, so forward bias it is ideal, forward bias it is ideal. So in forward bias it is ideal, reverse bias it requires 6 volt to operate. Now you have to plot the IV characteristics. Okay, how can you draw IV characteristics? So your diode is, until you don't apply 6 volt here, then diode will be in what condition?
Open.
See, diode has to Open, very good. Diode has to conduct. Okay, diode has to conduct. So conduction itself, it should have a some voltage here. If this voltage you're not applying, it is here in reverse saturation current. This is almost zero current. So in reverse bias, it is all it is actually open circuit until you don't apply this VZ voltage. Okay, so very good. So this is open. So so when this is open, no current is flowing in the circuit. Okay, but no current flowing circuit here, V0 is 0. So suppose it is 6 volt is here, 6 volt is here. So up to here, okay, up to here, and here is 6 volt up to here. Okay, when this much voltage is flowing, you cannot have current in the circuit. So you have not, you cannot have circuit current in the circuit here. Okay, so you don't have a current in the circuit in this part. After that, once its input voltage go beyond 6 volt,
Sir,
yeah,
6 volt is VZ volt, means VZ.
yes,
Okay, sir.
general voltage. Okay, so when it goes above 6 volt, that time general diode will conduct, and you can replace it by a battery. And always remember how I'm changing. I'm changing negative with positive. Okay, negative with positive. This you should remember. So 6 volt battery now. Okay, so once it is 6 volt battery now, so now maximum voltage it can come here is 6 volt, because maximum is 12, maximum peak value is 12. So when it is 12, 6 is here, 6 will come here. Okay, so now after, so initially it is 0 here, and now it will try to increase. Okay, and it will go up to maximum 6 volt here. Okay, and here again 0. Now what happens in reverse bias? Tell me. What happened in reverse bias? Reverse bias means negative cycle. So in positive cycle it was short circuit. Very good. In positive circuit, okay, in positive, this positive cycle it was reverse bias, but in negative cycle, it's a negative cycle. Okay, in negative side it is forward bias, and it will create a short circuit. So whatever voltage come will drop here. Okay, with negative sign like this. So whatever voltage come now here, that will come here again. Okay, here. Okay, again suppose you are coming a voltage drop here, so then again here, for some portion it will not conduct, then it will conduct, and then it will not conduct. Okay, so this is your this one. Okay, and this is your up to 6 volt here. So this is your 0 conduction, then 0, then whole drop again come to here, again 0 current. Okay, then this one, and you can have this one. Okay, so you can draw it nicely. So this is your this one here. Okay, and here you're starting. I'm not getting current. So this is the answer. So any doubt in this problem? Please tell me.
During
See, this is your during positive cycle, this is positive, this is negative, positive cycle, this is reverse bias. Okay, but this voltage varies from 0 to 12, 0 to 12. So until 0 to 6, it behave like a what? It behave like open circuit, no current flows. As voltage go beyond 6 volt, it takes 6 volt here. Okay, so initially there is no current. Now again current will voltage will start developing here, current will flow, and voltage will start developing here. So maximum voltage it can be developed here is 6 volt, because 12 में से 6 तो यहाँ चला गया. Out of 12, 6 is dropped here, so remaining 6 will drop here. So it will start from here 0 to maximum 6, while the input is from 0 to 12. Okay, and whenever input drops less than 6 volt, again this become opens, and there's no current in the circuit, and you have a zero output voltage. And in reverse cycle, this become minus, and this become plus, this become forward bias, and it can be replaced by a zero short circuit. So whatever voltage you're applying, that will come here. Okay, is it clear?
Yes, sir.
So in forward bias, it behaves as normal diode, right?
Normal diode, okay. And
Yeah.
this time they are saying there's a ideal diode, so there is no voltage drop. Okay. So I'm stopping here. Tomorrow we'll start. We will learn general diode. Okay. General diode, very important topic. So we'll there are 3 cases. We'll learn tomorrow one by one. Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.